record on this computer. Okay, there we go. So real quick from the top, we're trying to see the bigger picture because we want to be able to notice mathematically the forest instead of the trees first. Your first priority is what is the bigger structure? Mathematics has been defined as the study of structure. That is one possible interpretation of it. So being able to identify that structure first should be your top priority. And that means identifying the equations and noticing what type of function is this? What is going on? How does it create a graph? Okay. And not just a single function, but what about a composite function? This is where it gets confusing, right? These are easy. They're in the name. You just see, oh, it's got an x squared there. Okay, fine. It's a polynomial. Great. What about when you have multiple things together? Okay. And I don't just mean the typical composite functions, you know, oh, find f of g of x, fog, right? Get the little open circle in between the f and the g. I'm not just talking about how you can combine, here's two things, put them together. I'm saying, what about when you already encounter something that has multiple base functions in it? What is this function here? Is this a sine function? This whole thing, y equals? No. Is it a cosine function? No. It's a composite of the two. It's adding two things together, this addition of two parts. And so you need to notice that first. Same with z down here. My gosh, z is like crazy complicated. Z has not only x, it's got y in there, so it's got multiple variables going on. Okay, it's got x squared. Okay, so is z itself a polynomial? No, because it's got the division. Oh, shoot, that changes it. So now it's a rational function, right? And we spent some time studying rational functions. What does that ultimately look like? But in order to notice that, you need to be able to see first, oh, this is a thing. The parentheses are helping us here, divided by another thing. Then dive in and say, okay, what are each of those things? Oh, the first thing is a quadratic expression. The second thing is a linear expression. And that's a lot. That's a lot of processing. Okay? That skill, IDing the function structure, depends upon sub-skills. You need to understand function notation. I think that's the biggest weakness for most of you at this point is not being comfortable with function notation. You don't have mastery of it yet. You have familiarity. You might have understanding, okay? Understanding a concept means you can get the answer right. That's what that means, right? When you move from I can't do this at all to, oh, I get this, I can do it now, and you do an example, that's understanding. That's only the base level. You need to get to mastery. Mastery means you can't get it wrong. You get it right every time. That's the difference. And I think that's what we need to spend more time on next semester is focusing on mastery of some of these skills so that you can move up the pyramid. And it's the old stuff is not holding you back, okay? It's often joked in calculus that the difficulty of calculus is not calculus, it's the algebra, right? Often you will get a question in calculus class wrong because you did the algebra wrong, okay? As I've often mentioned myself, right? The number one source of all of your wrong answers for the rest of your math career will be negative signs. That will happen. And even with mastery of the concept of negative numbers, it still happens. And usually it's more of a notational error, right? It's such a small little thing in all of the stuff you're writing down, you lose track of it. And that happens. But that's the difference between understanding something and yeah, you get it done versus mastery. You get it done every time because you are meticulous. There's somebody at my door. I'm not expecting anybody. Hope it's no one important. All right. So not only the notation, but also understanding what the definition of a function is. Okay. And each of those understandings, those skills come from further breakdowns, right? You can't work with function notation until you really master variables. And the order of operations also plays a big role in how function notation works and how it doesn't, right? There's a difference. Parentheses mean two completely different things. Same with the function definition. The definition of a function depends upon the relation, because a function is a special type of relation. Remember, I think we did in this class, we defined algebra is the mathematics of relationships. Well, that's the core component right there. It also depends on understanding of sets, okay? Groups of things put together because they share some property. Sets in particular of numbers is actually how functions are properly defined. They are not machines that take an input and give you an output. Right? A function is a rule that assigns an item from one set to every item of another set. Okay? So it's based on knowing, okay, what is a set? To truly understand what a function is, you kind of have to have that knowledge base down first. Okay, is that making sense?
Mr. Apple, I think you should go open your door.
I'm in the middle of something important. They didn't buzz back. See, the problem with an apartment building is sometimes you get somebody who lock themselves out and they just go and like hit all the buzzers, hoping somebody will open the door for them. I'm hoping that's what it is. All right, this is more important though. All right. So, side note, I would recommend learning programming. Python is quick, easy to pick up and use. It's fairly simple, relatively intuitive, at least compared to some other more common ones out there. Don't start with Java or JavaScript. C++, fairly it's dynamic, so it works fast. Okay. Like that's my recommendation over the break. I have a different actual reading for you, just the beginning of our book. I want you to take a look at over the break. But really, if you want to get into this and truly understand it, I would recommend learning programming, okay? Because it will require you to think logically, to work with variables and functions in a more specific and more useful definitional environment. But for now, let's talk about that first branch, the function notation. How do you get to truly understanding and mastering function notation? You start with variables. So first up, a variable is not just a new name for the unknown. Get that out of your head. A better definition comes from, as they are used in programming, a variable is like a box that holds a value. So the variable itself has a name and it can hold different contents. Okay. So frequently we have, x is equal to 5. Well, that means we have a variable called x and it contains the value 5. I could have a variable called color. And right now it contains red. Red's not a number, but it is a value. It can be anything, okay? The name is color. It contains red. Usually we'll stick with single letter variables in math, okay, so that they become a shortcut, right? Writing out color every time. It's tedious. So you'll typically see this with word problems. They're like, we'll call time the variable t, right? Height will be the variable h. Okay, and so we'll shorten things to a single letter because it's way better than write x instead of the number you will use, but we don't know what it is right now because we're trying to define a general rule. So it works in all cases, but whatever it is, do this to it. Right? That's a lot of words. We shorten that into a variable x. Y, P. Doesn't matter what letter you use. If you want to go further with this, here are some resources, and I will be posting this slideshow on Google Classroom afterwards. But it includes a great definition there, a review of algebraic expressions, working with them. That's the first step with variables in algebra, is manipulating expressions. And a really good article that I came across about, let me see if I can go ahead and follow that one. I think you still see this, yes? Do you see the article? Make sure it's screen capture is capturing the right thing. About the many meanings of variable and how this has led to confusion. So I think reading about that would go a long way into helping you guys find your own sources of confusion and correcting that. So a very good article to read. Not super long, but not also super short. It goes down to about there, right? That's background credits. So there you have that. I highly recommend reading that. And if you prefer videos, Khan Academy always has a relevant video on whatever math. Okay, so what is a variable, right? Start with that. And based on coding, I would recommend a little intro to how programming treats a variable, because it's a really handy definition to have. You can take that definition directly into mathematics, and it will not hinder you. It can only it would enhance it to have that understanding there as well. All right, next up, order of operations. Okay, once you understand what a variable is, now you need to know how to put them together and how to manipulate them correctly. So order of operations comes into play. And the most important is parentheses and grouping, what they are doing, because they are what is creating a structure around the mathematical expressions and the operations involved, right? It's the heart of the organization, because they tell you what's inside is to treat it as one whole thing, i.e. another box, right? Parentheses create another box, and it says this stuff is in the box, and everything outside, right, operates on the whole box. That's what the distributive property is. When you distribute multiplication over a division, when you have, right, 3 times 2 plus 8, you are distributing the 3 across the 2 and the 8. 2 and 8 are happy inside their little box. When you multiply 3 times it, you're opening the box, taking everything out, and 3 was being multiplied by the whole box. Well, now it's got to multiply by everything that just came out of the box. Okay. And then, as I'm hope that you know this already. This is not new content, but perhaps a new way of thinking it, right? Exponents operation comes next in the order of analysis here. Once you have everything grouped together correctly, you will actually evaluate, perform the mathematical operations. Start with exponents because they are the most powerful. Start with then multiplication and division at the same time. They are of equal level. Okay, so from that, you would just move left to right within that, unless your division is actually a division bar, because division bars are secretly a grouping symbol. Okay, the numerator is separated from the denominator. You need to treat them as if numerator in parentheses divide by denominator in parentheses. That means, you got to go all the way back to the top, parentheses and grouping. And then finally, deal with any addition and subtraction. These are actually the same thing, because subtraction is just addition of a negative number. Some more resources on that. There's the cool math article on order of operations. That's pretty short and sweet. Math is Fun is a pretty good outline of content if you want a little bit more in-depth and more examples than cool math. And then here is a source of some practice, some little questions and answers. You can go on there, and I think this one, you click the little drop down and it'll reveal the full solution to you. So you'll manually check your work against that one. And Khan Academy, of course, has a good video. And this one is actually from Minute Physics about one of the most common errors and issues with PEMDAS, and that is if you think too much in order, right? Multiplication does not come before all the division. They are of equal value. And how you can actually think of all the order of operation so-called rules are just different versions of parentheses. So interesting video there. So finally, you can put those two things together. And from that, you'll be able to understand function notation. Those themselves do not create function notation, but it builds on top of those as its foundation. So remembering that a function assigns an output for any given input. Each function then has a name, something to refer to it as, an argument, which is its type of input, okay, and a rule. And that's usually written as an equation here, right? F of x equals this. So we have the name, it's f. Inside parentheses, right after the name, comes the argument, which is to say, usually some type of variable identifying the input, right? So it's a specific name for the variable on which the function depends. What's its inputs and what do I do with it? The rule then tells you what to do with that input. Okay, so this, whatever the argument is here, better show up somewhere later in the equation and tell you what to do with that. Okay, if this is f of y, but my rule here just tells me what to do with x, it's not a very useful rule. I don't actually have a defined function here. And the rule is just as an equation. It says take x, square it, and then add 3 more of it, and finally subtract 4. That's all that's saying. Alternatively, right? Think in more general terms. You're so used to seeing this all the time that you lose some of the meaning of what a function is and what it's capable of doing. Here is a function. I called it George. So love him and pet him and call him George. And George takes the argument Fred. Okay? This is just another variable. I just named it Fred instead of a single letter. Okay? And I have defined as my rule, function George takes Fred and does, if I can highlight just that, the opposite. Okay? Clearly, these are not the Weasleys because they are very much in sync with each other. But this George is the opposite of Fred. Right? Whatever Fred is doing, George is going to do the opposite. And I've defined that as a function. Okay? This allows me to do other things with it. Now I can take this idea, and pretend these are actual people. We're talking about a rule of behavior here, but I can now treat it mathematically. We could keep track of things that way, right? This is one of the uses of math. It gets applied to real life situations. Okay, we got to start coming up with a system to track that, a notation to be able to write things quickly and succinctly. Okay, mathematics is a language, and you need to understand the language there. If you don't know the notation, then you're going to miss out on all the ideas that are actually being talked about. When you see, if I can, let me just insert another physics here. Okay, we'll have force equals mass times acceleration. Okay, this is defining a relationship between these two quantities, m and a, to give us quantity f. You don't need to know what those are if you understand the notation. You can know how they relate to one another. I know that if I increase a, if I make that number bigger, this number will get bigger. If I make this number bigger, f will get bigger, right? They are directly correlated, right? All of that information is contained within this teeny tiny equation, right? This is why I always say mathematicians are lazy, right? We like to make things as short and sweet as possible. We get all of that into 1, 2, 3, 4, 5 characters, and this one isn't even necessary. See what that's doing there? It's like a shorthand. Okay, if you've ever seen like Chinese characters, how they get down to like one character represents a whole word, that in Western languages, we would write out with all those different letters. And so the space that it takes up is much shorter. Right? That's what we're doing here. So for further resources on function notation, if you think you've got variables and order of operations down and you're ready to move up, get to mastering function notation. Here are some resources I would recommend. MathBits Notebook is a wonderful website with really good explanations for things. It's not as fun as Cool Math, but is a little more thorough, I guess, and a little more classic styling than to what you're used to. So they've got a good article there. Cool Math has a good brief overview of function notation. Here is a practice from MathBits notebooks themselves. This is actually an online interactive multiple choice. You can click the buttons and submit your answer, and it'll tell you how you did. And if you need even more practice, here is a link to a worksheet. It's got 2 full pages of exercises, and the answers are included at the end, so you can check your work there. And a couple of videos. Eddie Wu is a really excellent teacher from Australia, I believe. And he's got his class lesson on function notation itself. I highly recommend watching that. And if you have more time, from Professor Rob Bob, he has a really good video on function notation. He goes into a little more detail and more examples. It's a longer video. I would also recommend that if you have the time there. Okay, speaking of time, how are we doing here? 7 minutes left. Okay, that'll do it for part 1. Part 2 will be function definition, and I will have to address that another day. I hope to put a video of that together for you tomorrow. So look out for a post on Google Classroom on this if you need this refresher. I know a lot of you are doing really well in the class. That's great. That's by design. I've made it simple enough that you can pass the class. I'm not worried about that. But I am suddenly getting worried now that maybe we have missed some fundamental concepts here that are going to leave you struggling later. And I don't want to do that. Okay. At this point, are there any questions from any of you? Okay, feedback. Is this helpful? Is this useful? Is this nonsense? Helpful, useful, still a little confusing. Okay. Now, let me end with this. Back to my diagram here. This is not the bottom of the diagram. This is not the top of the diagram. IDing the function structure is one skill that will support other skills as you go along. And understanding variables, of course, is not something you can just pick up out of the blue. That does depend on all the other middle school math concepts. You have to know what numbers are first, right? Before you can get into a variable that could be any number, you got to understand the numbers first. And so this is not the bottom of the pyramid. There's many more things underneath all of this that I'm not covering because, as I said, those are like definitely middle school level. I'm hoping that basic, like elementary, pre-algebra numeracy stuff you're okay with. If anybody is having issues with the actual addition and multiplication, I honestly don't know how you made it this far, but contact me, send me a private message. It's absolutely okay. Do not be embarrassed about it. It's not your fault. It's your teachers that let you just skip on into the next year without knowing these things. Okay, I will help you. We have time. We can fix this. All right? Don't panic. Another one, a little confused in general, but this has helped. Okay. So yes, so definitely a part 2 coming. I'm going to go ahead and find the stop recording button. Where's that? Pause recording, stop recording. There we go.